July 4th, 2026. Today, the United States of America celebrates its 250th birthday, a quarter of a millennium since the signing of the Declaration of Independence. And to mark the occasion, astronomers have pointed us toward a most poetic celestial tribute. Tonight, if you look toward the southwestern sky, you will see Spica, the brightest star in the constellation Virgo, a brilliant blue-white point of light. Spica is approximately 250 light-years away. That means the light reaching your eyes tonight, on this very evening, began its journey across the cosmos around the year 1776. The photons hitting your retina have been traveling through interstellar space for exactly as long as the United States has existed. It is a beautiful reminder that when we look up at the stars, we are not seeing them as they are, but as they were. We are looking back in time. And on this particular night, we are looking back to the very birth of a nation, to a time when the world was on the cusp of an industrial revolution, when steam was power, and when our understanding of the universe was still in its infancy. In 1776, Sir Isaac Newton's laws of motion had been around for nearly 90 years. Copernicus and Galileo had already dislodged the Earth from the center of the universe. But the nature of the sun itself was still a mystery. Many believed it was simply a giant burning lump of coal. No one knew about nuclear fusion. No one knew about the quantum realm. No one knew about the vast, expanding cosmos of galaxies that stretched beyond our own Milky Way. The scientific revolution was well underway, but its most spectacular chapters were yet to be written. And that is the story of July 4th, not just as a day of independence, but as a day of discovery, a day that has become a landmark in the history of physics. Because July 4th is not only the birthday of a nation, it is also, remarkably, a day that marks the death of one of the greatest scientists who ever lived, the patent of one of the most consequential and terrifying inventions in human history, and the triumphant announcement of one of the most important discoveries in modern particle physics. On July 4th, 1934, Marie Curie passed away. A pioneer in the study of radioactivity, she was the first woman to win a Nobel Prize and remains the only person to have won Nobel Prizes in two different scientific fields, physics and chemistry. Her work on radioactivity opened the door to the quantum world, revealing that atoms were not solid, indivisible spheres, but complex structures with nuclei that could transform and decay. On that same day, July 4th, 1934, the Hungarian physicist Leó Szilárd filed a patent for the nuclear chain reaction. Szilárd was a visionary and a showman, a man who thought in grand, often terrifying terms. He understood that if you could find an element that released more neutrons than it absorbed when it fissioned, you could create a self-sustaining chain reaction, releasing an almost unimaginable amount of energy. His patent was a premonition. It was the blueprint for the atomic bomb, a weapon that would not only end a world war but would fundamentally alter the course of human history. And then, 78 years later, on July 4th, 2012, scientists at CERN announced the discovery of a new particle consistent with the Higgs boson. The Higgs boson is the quantum of the Higgs field, a field that permeates all of space, a cosmic molasses that gives fundamental particles their mass. Its discovery was the final piece of the standard model of particle physics, a monumental achievement that had been nearly 50 years in the making. It was a moment of pure, unadulterated scientific triumph, a confirmation of our deepest theories about the nature of matter itself. Feynman would have been captivated by all of these threads. He would have appreciated the profound strangeness of Spica, a binary star system of two massive blue-white stars locked in an orbit so tight that they complete one revolution every 4 days. The larger star is nearly 8 times the diameter of our Sun, and together they shine at over 12,000 times the luminosity of our Sun. He would have reveled in the physics of that distant light, the quantum mechanics of photon emission, the general relativity of space-time curvature. He would have understood that when we look at Spica, we are seeing a system that likely contains elements forged in the hearts of previous generations of stars. He would have been in awe of the sheer scale and beauty of it. But July 4th, 2026 is not just about looking back in time. It is also about looking forward. Because on this day, as the United States celebrates its 250th birthday, the world of physics is experiencing a profound transition. The Large Hadron Collider, the very instrument that discovered the Higgs boson, has just been switched off. After more than a decade of smashing protons together at nearly the speed of light, the great machine has fallen silent, entering a 4-year shutdown period for a major upgrade that will transform it into the high-luminosity LHC, capable of producing up to 10 times more data. The LHC will not awaken again until 2030. It is a somber, reflective moment, a time to take stock of what we have learned and to prepare for the next great leap forward. But while the LHC sleeps, other instruments are wide awake and making history. On this very day, the German-British gravitational wave detector GEO 600 is holding its 11th and final open day. Located south of Hanover, Germany, GEO 600 is a pioneer in the field of gravitational wave astronomy. It has served as a global think tank for research, testing technologies and techniques that would later be crucial to the success of LIGO and Virgo. Visitors to the open day can speak with researchers about the current state of the field and learn about the contributions of GEO 600 to international research. It is a poignant moment, the final opportunity for the public to see the detector up close. GEO 600 will cease operations at the end of 2026. It is the end of an era, but it is also a celebration of everything that has been achieved. Gravitational waves, the ripples in the fabric of spacetime predicted by Einstein a century ago, are now a routine tool for astronomy. We have heard the chirp of merging black holes and the ring of colliding neutron stars. We are using them to explore the universe in a completely new way. The fact that we can even have an open day at a gravitational wave detector, the fact that the public can walk in and ask questions about these cosmic phenomena, is a testament to how far we have come. And there is another mission happening today that embodies the spirit of scientific ingenuity and the drive to extend our reach. NASA has launched a robotic mission to rescue one of its aging space telescopes. The Neil Gehrels Swift Observatory, a satellite that has been studying gamma-ray bursts and other high-energy cosmic phenomena since 2004, has been losing altitude due to atmospheric drag. Without intervention, it would eventually burn up in the atmosphere. So NASA has sent a robotic spacecraft, named Link, built by Catalyst Space, to rendezvous with Swift, capture it, and push it into a higher orbit. This $30 million mission is an unprecedented effort to give an aging satellite a second life. It is a beautiful metaphor. We are not just building new instruments. We are learning to repair, to extend, to salvage. We are learning to be good stewards of our technology, to ensure that the investments we make in science continue to pay dividends for years to come. So let us bring all of these threads together. On July 4, 2026, we have Spica, a star whose light began its journey when the United States was born. We have the legacy of Marie Curie and the patent of Leó Szilárd, reminding us of the double-edged sword of scientific discovery, the power to heal and the power to destroy. We have the discovery of the Higgs boson, a triumph of collective human intellect. We have the LHC, sleeping in its tunnel, awaiting its rebirth. We have GEO 600, opening its doors for the last time. And we have a robotic spacecraft on a mission to rescue a telescope. Each of these events is a piece of a larger story, the story of our relentless quest to understand the universe and our place within it. Feynman would have loved all of this. He would have loved the sheer variety of it, the way that physics connects the distant light of a binary star to the quantum field that gives matter mass, the way that the same curiosity that drives us to build billion-dollar particle accelerators also drives us to rescue a satellite in a decaying orbit. He would have appreciated the humility of looking at a star 250 light-years away and knowing that we are seeing the past. He would have appreciated the audacity of building a machine to detect ripples in spacetime. And he would have appreciated the courage of trying to save a telescope, of refusing to let a scientific instrument die. Because for Feynman, science was not just a profession. It was a way of life. It was about wonder, about curiosity, about the sheer joy of figuring things out. It was about never being satisfied with easy answers, about always asking why and how and what if. There is a famous story about Feynman that I have always loved. He was once asked by a student what he thought was the most important thing he had learned about the universe. Feynman thought for a moment, and then he said, "The world is so wonderful that I am lucky to be alive in it." That is the spirit that animates all of these discoveries, the spirit of wonder, of joy, of gratitude for the sheer fact of existence. It is the spirit that drove Marie Curie to toil in her lab, that drove Leó Szilárd to imagine the unimaginable, that drove the thousands of physicists at CERN to build the LHC, that drives the engineers at Catalyst Space to build a robot to rescue a telescope. It is the spirit that we can all share every time we look up at the night sky and see Spica shining in the southwest, a reminder that we are part of something vast and beautiful and infinitely surprising. So tonight, go outside. Look at Spica. Think about the light that is reaching your eyes, light that began its journey in the year 1776, light that has traveled 250 years across the cosmos to reach you. Think about the fact that this light is made of photons, that these photons are governed by the laws of quantum electrodynamics, the very laws that Feynman helped to discover. Think about the fact that the same physics that describes the light from Spica also describes the light from the stars, the light from the supernova remnants, the light from the pulsars. Think about the fact that we, tiny creatures on a small planet in an ordinary galaxy, can understand all of this, can reach out across the vast distances of space and time and grasp the underlying order. It is a miracle. It is a gift. And it is the greatest adventure that humans have ever undertaken. As the United States celebrates its 250th birthday, we are reminded that our understanding of the universe has grown exponentially since 1776. We have gone from wondering if the sun was a lump of coal to knowing that it is a nuclear fusion reactor, powered by the very processes that Hans Bethe painstakingly calculated. We have gone from seeing stars as fixed points of light on a celestial sphere to understanding them as distant suns, many with their own planetary systems. We have gone from believing in a static, unchanging cosmos to knowing that we live in an expanding, evolving universe that began with a Big Bang 13.8 billion years ago. And we are still learning, we are still exploring, we are still asking the questions that have driven us for centuries. What is the nature of dark matter? What is the nature of dark energy? Is there a theory of everything? Are we alone in the universe? These are the questions that we will answer in the next 250 years. And the foundation for those answers is being laid today in the work of the scientists and engineers who are pushing the boundaries of what is possible. They are the ones who will build the next generation of telescopes, the ones who will analyze the data from the next generation of colliders, the ones who will design the missions that will take us to the stars. They are the heirs to Feynman, to Curie, to Szilárd, to the thousands of physicists who have dedicated their lives to the pursuit of knowledge. And they are the ones who will continue the journey that began with the first humans who looked up at the sky and wondered what it was. The LHC will wake again in 2030, reborn as the high-luminosity LHC, more powerful than ever. GEO 600 will fall silent at the end of 2026, but its legacy will live on in the detectors that follow. The Swift Observatory, if the rescue mission succeeds, will continue to study the most powerful explosions in the universe, and Spica will continue to shine, its light a constant reminder of our place in the cosmos. The universe is a vast and wondrous place, full of surprises, and we, the curious ones, the ones who refuse to stop asking questions, are the ones who get to explore it. Stay curious, my friends. The universe is speaking, and tonight it is speaking through a brilliant point of light in the southwestern sky.